Here are a few examples on how to use inverse binomial n and inverse binomial on your CAS. So we can find the least number of trials required for a given cumulative probability when we're given also the probability of success and the number of successful outcomes. Here's our first example. I'll give you a moment to read it. Okay, so first we need to define our variable and our distribution. So we write this down. It's really important that you write this down in your answers. Let x be the number of times Jack hits the target, and x is distributed binomially. N trials, we don't know what this number is yet, and our probability is 0.3. We want the probability that x is greater than or equal to 1, that's at least one shot hitting the target, to be greater than 0.99. Now we're going to rewrite that as, remember, cumulative probability is up to a certain amount. This is over a certain amount. So I can rewrite that as x is less than or equal to 0. Now in this particular situation, that's the same as x is equal to 0. But if this was any number greater than 1, then this obviously would be the less than or equal to would make more sense. And because I'm looking at things less than this, then I need to look at my probability being less than 0.01. Now, on my CAS, in a calculator page, I go to Menu, and then Probability, and then Distributions. Then Inverse Binomial N isn't on this first menu, so we need to scroll down, and you'll see there it's at D. So I select that. Now, the information that I've been given in the question, I've written it again here for you. Our cumulative probability is 0.01. Our probability of success, that's what we're given in the question, is 0.3. And our number of successes is 0. That's from here where we rewrote our probability. We'll talk about matrix form in a moment. That gives us 13, which means that the minimum number of shots he needs to take is 13. What that means is if Jack shoots 13 arrows at the target, then the probability of at least one of them hitting will be greater than 0.99. Alternatively, we could say the probability of 0 of them hitting is less than 0.01. Now, if we wanted to have a look at the matrix form box, so we go through the same process. If I select this box, then it actually gives me two values. It says at 12, the probability that he hits it 0 times is 0.013, so that's too high. And so 13 is the first time our probability falls below 0.01, so that's why our answer is 13. Now, this works for cumulative probability, so this when x is less than or equal to something. When we have questions where the exact number of successes is given, or the thing that we're trying to find, we cannot use this in this situation as it just refers to the cumulative probability. So let's have a look at a second example. I'll give you a moment to read it. So again, let's define our situation. This time X is going to be the number of times Harry hits the target. And this X is distributed binomially. N trials, we still don't know what that is, but our probability of success is 0.6. We're looking for how many trials will give us a probability where X is equal to 5 is greater than 0.25. One way to do this, I can open a graphs page. So there I said Control I for insert, and then I'm going to add graphs. And I can type in, so using the letters at the bottom, binom PDF, then N is the thing I'm looking for, but because we're in graphs, your calculator only wants to think about X's and Y's, so we're going to change the N to an X, and the probability is 0.6, and the number of successes is 5. Press enter, it does nothing, that's what we're expecting. We can press Control T to view the table, and see here, our probabilities round to 0 effectively here. We're looking for when they get to be greater than 0.25. So if he takes 5 shots, then the probability of him hitting the target 5 times is 0.077. So we keep on going through till we get to a value that is greater than 0.25. And so this tells us that 7 trials gives us a probability of 0.26 that he hits the target 5 times, and that's the first time that our probability is greater than 0.25. So the minimum number of trials, or the minimum number of shots, would be 7. Alternatively, we can open a calculator page and we can define the function bin for binomial n. Then we can use the walrus face button, so that's the blue bit above the brackets and matrices and stuff here. And instead of typing binom PDF in, I can go to Menu, Probability, Distributions, A for binomial PDF. My number of trials is n, my probability is 0.6, and my x value is 5. So I've defined that function now. Then I can just type bin 5. No, that's too small a probability. Let's see what happens for 6. That's still too small. See what happens for 7. That's greater than 0.25, so 7 is the minimum number of shots. And I could carry on finding the probabilities for this. Instead of testing them, because if this were quite a large number, then you might not want to do all of that typing. What we could do is, after we've defined our binomial PDF, we can open a lists and spreadsheets page and Control T to insert table. We'll ask you, we want bin, that's the one that we've been using, and it creates all of the values like we saw before on the graphs version. So any of these would be acceptable ways to find the answer to this question. We can also find the minimum number of successful outcomes for a specific cumulative probability, given the probability of success and the number of trials. This is the inverse binomial function of CAS. Here's an example. I'll give you a moment to read it. Okay, so we need to define our x is the number of times Jack hits the target. X has a binomial distribution. 10 trials, he shoots 10 arrows, probability of success is 0.3. The probability that x is greater than this value that we're looking for is greater than 0.9556. So we can go to Menu, Probability, Distributions, Inverse Binomial. So if I see there's inverse binomial and there's inverse binomial n. We were using inverse binomial n before, now we're using inverse binomial. So my cumulative probability is given to me in the question, 0.9556. My number of trials is 10, that's how many times he shoots an arrow at the target, and the probability of success is 0.3. That returns a value of 6, so the range is from 0 to 6 trials. If we select the matrix form box, so if I go through all of those again, then that gives me, as before, the value for 6, probability at 6, and the value at 5. So what this means is the probability of him, the cumulative probability of him hitting the target up to 6 times is, for 6, 0.9894, which is the first time it's greater than 0.9556, because as we can see here, the cumulative probability up until hitting it 5 times, so that's hitting it 0, 1, 2, 3, 4, or 5 times, that cumulative probability is just 0.9527 if we round up there. Alternatively, with this, we can open a graphs page and we can graph the function binomial CDF and you can see there it gives us these steps. I'm just going to graph also value, so Control G to input a new graph, the value of the probability that I'm looking for, so I'll know when my values go over. Now we're too zoomed out here, so let's zoom in so we can see better. We can't have values below 0, so we don't need that. We've got 10 things happening. Let's go up in stages of 1. We don't need to go below 0 with the y. We don't need to go above 1. So I'm just going to go slightly over 1 so it makes it easier to see. So this is what we have here. This is from 0 to 1, which is the same as saying 0, and so on, all the way up. So here is where we go over the line for the first time. But it's quite hard to see there, isn't it? So what we can do is Control T to view the values in a table, and we can scroll down to see that 5 is not quite enough, so we need to go to 6 to have a cumulative probability of over 0.9556. There's a few different ways of using these. You only need to know one. You don't need to have 3 different ways of answering a question. So pick one that you like and practice using it and make sure that you can remember the whole process.